Today we're going to talk about graphing secant and cosecant, and we will use sine and cosine in order to graph secant and cosecant. So first let's review the relationship between sine and cosecant. Remember, sine and cosecant are reciprocals of one another. Ooh, that handwriting's awful, sorry. And then the relationship between cosine and secant is also, they are reciprocals of one another. So we're going to be using sine, the reciprocal of sine, to graph cosecant, the reciprocal of cosine to graph secant. Let's review the reciprocal values of 0. Remember, 0, to write that as a fraction, is 0 over 1. The reciprocal of 0 over 1 is 1 divided by 0, which is undefined. So the reciprocal of 0 is undefined. Reciprocal of 1/2, that's easy. That's 2 over 1, or 2. The reciprocal of 1 is 1, and the reciprocal of negative 1/2 is negative 2. Notice the reciprocal's signs do not change. We only invert the denominator and the numerator. So remembering this relationship, let's graph sine so that we can graph cosecant. So the instructions state draw two periods of y equals sine x. I'd like you to draw them both to the right of the y-axis. So remember, this is y equals 1 sine of 1x. So the 1 here, the coefficient, the one that's the coefficient of sine, reminds us that the amplitude is 1. So our max is 1 and our min is negative 1. The coefficient of x is 1, so that reminds us our period does not change, so our period is still 360 degrees. Then we divide that into 4 equal parts. Halfway from 0 to 360 is 180. So our first period for sine, we begin at the origin, max, middle, minimum, and back to the middle. So let's draw one period of sine. And I apologize for the sloppiness. It's hard to write on the slate. And then our second period is still 360 degrees in length. So 360 plus 360 is 720. Mark 4 equal parts. And let's draw our second period of sine. Okay. We're going to use this graph to sketch y equals cosecant x. So let's review. At this point, the sine of 0 degrees is 0. The reciprocal of 0 is undefined. To show that a graph is undefined, remember we use a vertical asymptote. Okay? Let's move on. The sine of 180 degrees is 0. The reciprocal of 0 is undefined, so we have another vertical asymptote here. Remember what I'm doing? I'm using the given graph of sine to sketch its reciprocal function, cosecant. Again, we're at 360 degrees. The sine of 360 degrees is 0. The reciprocal of 0 is undefined. So everywhere sine crosses the y-axis, everywhere sine crosses the x-axis, sine has a value of 0, and the reciprocal of 0 is always undefined. So we went through and found all the places where the graph of sine crossed the y-axis. That's where sine. And so we plotted the reciprocal of 0, which is cosecant. So we've plotted the reciprocal of 0, which is undefined. So if currently everywhere sine equals 0, cosecant is undefined. Show that by a asymptote. Next, let's go through and pick everywhere sine equals 1/2, cosecant will equal 2. I'm selecting this value because it's an easy value to write the reciprocal of. I could have chosen square root of 3 over 2 or square root of 2 over 2, but this is just an easy value. So we'll say roughly here sine equals 1/2, cosecant equals, so I'll put a point at sine equals 1/2, cosecant equals 2. Sine equals 1/2, cosecant equals 2. Sine equals 1/2, cosecant equals 2. Now I'll go through and everywhere sine equals 1, I'll plot the reciprocal of that, which is positive 1. Sine equals 1, cosecant equals 1. Sine equals 1, cosecant equals 1. So now I'm going to connect those dots, and you see that cosecant looks somewhat like a parabola. Whoops, these should be connected. So where sine opens down, cosecant opens up. The inverse of opening down is the reciprocal of opening down is the reciprocal opening up. Let's go through negative 1/2. Everywhere sine equals negative 1/2, cosecant will equal negative 2. Negative 1/2, negative 2. Negative 1/2, negative 2, negative 1/2, negative 2. Everywhere sine equals negative 1, cosecant will equal the reciprocal of negative 1, which is negative 1. The reciprocal of negative 1 is negative 1. And then I'll connect those dots. So as you can see, the graph of cosecant is here in black. I first graphed sine, and then I placed vertical asymptotes everywhere sine crosses the x-axis, and then I connect the maximum of sine and open cosecant up. Connect the minimum of sine and cosecant opens down. And I apologize for the sloppiness. I'm writing on a slate and that is a little bit difficult. Okay, let's do the same thing for example E. Draw 2 periods of cosine. So remember, and at this time it says draw 1 period to the right and the left, just to practice moving in separate different directions. So we have 360, 180, 0, negative 180 degrees, and negative 360 degrees. Okay. Cosine has a max of 1 and a minimum of negative 1. I'll go ahead and place my points. Remember, it starts at the maximum, then it crosses halfway, minimum, crosses halfway, maximum. And then side. And then as we move from left to right in this direction, cosine is at the maximum, middle, min, middle, and max. So let's draw cosine. And I'll try to see if I can not be so sloppy on this slate. It's not working. Okay. Please pretend that I hit all my points. Okay, we're going to use the same concept for graphing y equals secant x as we did when we graphed cosecant. Secant is the reciprocal of cosine. So everywhere cosine crosses the x-axis, y equals 0. And the reciprocal of y is undefined. So we will have vertical asymptotes there. Everywhere that cosine opens down, secant will open up. Where cosine opens down, secant will open up. Cosine opens down, secant will open up. Everywhere cosine opens up, secant will open down. Everywhere cosine opens up, secant will open down. Example F says, use the graph of y equals -2 cosine 2x to graph y equals -2 secant 2x. So you would sketch the cosine equation first, then use that to draw secant. On G, you would sketch the graph for sine first, then use that to sketch cosecant. So I'm going to stop the screencast now. I'd like you to graph F and G, the cosine and the sine, then secant over the cosine, cosecant over the sine, and then turn back on and check your work, okay?